Good morning, good morning. Good morning, good morning. This is today's attendance. I'm gonna copy and paste this into the chat. This is your attendance for today. Good morning, good morning. We're gonna wait for more people to come. Hop on the chat. How is everyone's morning so far? If you just got here, this is today's attendance. Sleepy? I feel you. Good morning, Roxana. All right. Okay. So we're going to give our people a few more minutes. A bit awake. Okay. That's interesting. So today's National Day is really interesting. Today's National Day is Earth Day. How many of us actually knows that today is Earth Day? Have you guys celebrated Earth Day before? Yes, no, maybe. No. Okay. That's fair. That's fair. So Earth Day actually promotes international awareness of environmental protection and earth conservation, which is really cool. And I think it's a really major topic. I was watching Godzilla for the first time with my parents yesterday. And you can see here is like a very, very interesting quote from one of the characters. And I thought it was really interesting. You guys can read it. It's really long. And I have some fun facts right here. For those of us who just got here, this is attendance. But we were just talking about Earth Day. Today is Earth Day, and we have some fun facts on the side. The question I have for you guys is, what is something eco-friendly that you've done or can do on a regular basis? I know for me and my family, we've been bringing our eco bag while we go grocery shopping. So that's what I've done every day, trying to be more eco-friendly. What's something that you or your family have done? Feel free to chat, the group chat. You do that too, Roxana? That's awesome. Yeah. Unfortunately, Japan is notorious for over packaging. So it's taking some time for people to get used to it. But we will get there, hopefully. All right, for those of us just hopping in, this is our attendance today, and we're just having a very short conversation about Earth Day. Yeah, I would love to hear more about what you guys have been doing. Ah, that's a really good one, Zephyr. Yeah. Oop, a lot of people showing up. Give me a second. Let me let them in. As always, attendance. When did you start skateboarding, Zephyr? Ohio, Moses. All right. Okay, give me a second. There are a lot of people popping in. Around 5th grade. Was it hard to pick it up? Oh, don't leave yet, people. Don't leave yet. We're going through a lesson today. I picked up skateboarding in college. I have way too many wounds and scars on my knees. It's not cool. All right. Okay. I think we have more and more people coming up, which is really awesome. So as always, this is our attendance. Yeah. Okay. I think that's a good amount of us. We're going to move on to today's announcements. So for announcement today, for the past 3 lessons, we've done polynomials. Today, we're going to wrap up the polynomial unit. So here we go. All right, as always, office hours reminder. For those of us who have missing assignments, I will be calling you into office hours, obviously not when you have class, anytime between 10:30 in the morning to 12 p.m. And every Tuesdays and Thursdays from 10 a.m. to 12 p.m., I'll be here in this Zoom link for office hours. And on Fridays, I know that Miss Mac usually hosts office hours. Is it from 2:15? You guys can correct me if I was wrong. But I'll also be here this Friday. So if you want to work on this assignment or any past assignments, let me know. Okay. Okay. So we're gonna go through some of the questions that we were confused a little bit, like as a group. Okay. So the first question we have here is this. Can someone tell me or just come off mute or, message me, private message me, what is wrong with this chat? What is wrong with the sketch? So the single roots and the double root identification were actually correct. So what is the issue with the sketch here? By the way, this is today's attendance, everyone. Yeah, so it might be a Desmos issues because I know it's really hard to draw. But when you have a double root, you want to make sure that you have your parabola here. So the curve should happen at the point. So that's like a very good reminder. So it should have looked something like this if I have to draw it out. It would look something like this. And then you have that parabola, and then you have that straight line going through. Okay, all right, let me stop to annotate. So that's the issue with this one. We want to make sure we have this parabola drawn out. Great. The next question is this. Oh my goodness, sorry. What is wrong with this? Again, correct identification. We know the multiplicity, which is the double root. We notice the double roots. We know the solutions. Those are all correct. But what's wrong with this graph? What do we usually have to do with double root? Feel free to come off mute or just comment in the chat. Yeah, so at double root, we're supposed to bounce at the point. So you see how here we just went through this point. We're supposed to bounce at this point. So it would look something like this. We bounce at this point, right? And then we also want to bounce at this point. We want to bounce at when x is -1 and when x is 3, because we identified that these two solutions are double root. All right, just a quick reminder here. Okay. Let's move on to the next one. So this one is, I was really amazed with the notes that you guys were doing throughout the problems all across the board. And I have some great examples. There were a lot more, but those were the examples I saw when I started grading. Let me clear my page. Cool. Yeah, so shout out to Nayeli, shout out to Marcy, shout out to Daryl, Jessica, and Leslie. They were awesome. You see how, say, look at Jessica. She has like highlighted notes across the board. And Leslie, she differentiated the points by having different colors. Naomi made her dots, like her points, super big. Marcy also made notes of the solutions on the board. And we also have Daryl making those notes. So good job, everybody. Awesome. Okay. Oh, that's pre-calc. So I'm going to launch a poll and you're going to tell me whether you need a minute or so or you're ready for class already. But let me launch that right here. Okay. So we're gonna grab our notes for assignment 37. So this is the link to the notes. Give me a second. This is notes to us lesson 37. You guys should be able to access it. In the meantime, I'm gonna share my screen. Okay, seems like some people need a minute. Just take that minute, take your pen, take your paper, and we will get started really shortly. Cool. I think this is it. All right, team. So today we're on notes 37. We're talking about key features of polynomials, and this is the last lesson on our mini unit of polynomials. We're gonna be looking into zeros, the y-intercept, turning points, and this thing called end behavior. So we've seen zeros and y-intercept quite a lot at this point. So the new topics that we have today are turning points and end behavior. All right. So the first thing that you should have written down in your notes is this function. All right, you want to write down y equals x plus 2 times x plus 1 times x minus 2. Okay? All right. Can someone tell me how I can find my zeros? Or what my zeros are? Feel free to come off mute. Feel free to chat the group or private message me. How can I find my zeros? Thank you, Roxana. So as Roxana correctly pointed out, my zeros are at -2, -1, and 2. Roxana, can you come off mute and tell us how you got these zeros?
I got these zeros because it's like the opposite of them, and
Yeah.
the graph it shows each and one of them being a negative and positive. So
That's awesome. Yeah, on the graph, you can find it right here, right? It's where our function, or the squiggly line, touches our x-axis. Awesome. And you correctly pointed out, we flip the signs, right? We flip the signs in the function to arrive at the zeros. Awesome. Thank you. Okay. The second part, how do I find the y-intercept? How can I find the y-intercept? So here we have a hint. We have hint, y-intercept is when x equals 0. So how do I identify this point on this graph? When x equals 0. Yeah. So we have this. So let's use our highlighter too. We're looking at this line, right? When x equals 0, the only thing that's moving, the only thing that's changing is the y that we're looking for. So for this function, we're looking here at where the equation touches the y-axis. So here we see that it's at -4. And that's how we find the y-intercept. Yeah, awesome. So that's what we got for the y-intercept and the zeros. This is what we've been doing for quite some time. So hopefully it's like a review for everybody. And now we're gonna look at this thing called the turning points. Turning points. Give me a second. We have people coming in. I'm just gonna drop the attendance here again. coming in. That's a lot of people coming in. All right, for those coming in, this is the attendance for today. And we are on note 37. I'll link it right here as well. Great. So this thing called turning points, we have two features. We have this thing called local minimums and local maximums. So what it just means is within like a certain region, where is my maximum, which is the highest point, or my minimum, which is like the lowest point. So we often call it either as local minimums and maximums or regional minimums or maximums. So you should have this part written down. This is important. And how do I find that? So we find that by looking at where we have the bounce or the parabola. And we usually put a circle around it or a box. So here what I see a box, I see a parabola right here. So I'm going to circle it or just put something around it. And I also see another parabola right here. So I'm going to box it. Okay. So I know that at this point, the part that I just boxed, this is the highest point, right? I know that's the highest point because all those points around it are not as high as this one point. So if you remember from maybe geometry in the past few years, we have this thing called a vertex. So when we have a parabola, the lowest point and the highest point of a parabola is called vertex, right? So this is what we're looking for. We're looking for the vertex. So once we've identified this point, all we have to do is to see what the coordinate is. So to find the x value, we jot down this way. So we see that, hey, this is in between -1 and -2. So I'm just going to say -1.5. And for the y, we're going to move to the y-axis and see what this number is. Looks like a 1 to me. So I know my local maximum here is at -1.5. Make sure you have your x first and 1. So this is our local maximum. So far, does this make sense? If it does, please give me a Y in the chat. If it's a little confusing, let me know. Private message me. All right, thank you. Cool. All right, I'm going to move on to a very similar idea, the local minimum. So here we have the second box, right? I have this box because we have another parabola, but this time it's at like a valley, right? It's going down. So all the points around this point is not as low as this point itself. So I know this is my local minimum. So I'm going to do the same thing as I did with the maximum. I'm going to come, that's the y. So I'm going to jot down from my x. So it's telling me that, hey, my x is at 1. And then I'm going to move to the left to see my y. My y is at -6. And that's how I tell that my local minimum is at 1 and -6. All right. Okay. We're going to move on to our next point, next concept called the end behavior. So what end behavior does, it defines the graph as the x gets either really, really small or when the x gets really, really big. All right. So this is the concept of infinity, right? Might sound a little bit funky, but we will get into it later. So here we have, so how can the x get really, really small? So here I see that my x, the smallest x on this graph that's labeled as a -4. So how do I get a very small x? What do I have to do? How do I extend which way to get a very small x? It's okay, it's a new concept. So feel free to try and think about how to get a very, very small x. What do I have to go? Like, in what direction do I have to go to get a very small x? Yeah, Roxana, that's awesome. You want to go very far to the left to get a very small x. So like -4 is not very, like, it's a small number, but it's like, compared to like -1,000, it's not that small, right? So you can go very, very far to the left. So when I say end behavior as x approaches -infinity, it means that as our x gets very close to -infinity, it's going very, very far to the left. So we have a very, very large number that's negative, which makes it a very small number. So what I want to do is I want to look at this. I want to look at the end of our function that's on the left side to tell me whether I'm going upward or downward, right? So in this case, when our x is approaching -infinity, meaning it's going very, very far to the left, our function is going downward, right? So when it's going downward, we describe it as our y also approaches -infinity. So if it's going downward, it's -infinity. If it's going upward, it's infinity. Okay. So that's how we describe the -infinity when it's going very, very far to the left. And the next concept we're going to look at is approaching infinity. So we've known that, hey, to get a very, very small x, meaning approaching -infinity, we want to go to the left. So can you guys have a guess at which direction we're going to go when we want to approach infinity? You want to approach infinity. Meaning we want to get an x that's very, very big. That's awesome, Roxana. So if you want to get a very big like x value, like 1,000,000, you want to go very far to the right, right? You want to go very far to the right to get a big x. And this is what we call as x approaches infinity. And let me write it out as x approaches infinity. All right. So this is called as x approaches infinity. So what I want to do is I want to look at the direction of the end of my function on the right side. So I can see that, hey, on the right side, the end is going upward. So you know how we talked about earlier, if it's going downward, it's y approaching -infinity. But if it's going upward, our function going upward, it will be as y approaches infinity because we are moving upward. Okay, it might still sound a little bit iffy, but that's okay. I'm going to launch a poll and you guys are going to tell me whether or at which point you guys are on, whether you're still confused about something else. Oh, not this one. Oh, sorry, not that one. All right, you guys can tell me. I'm gonna launch this poll called the multiple choice. And before you press anything, I'm gonna have, if you're still confused about the zeros, you're gonna put A in the poll. If you're still confused about the y-intercept, you're gonna put B. If you're still confused about the turning points, the local maximum and minimum, you're going to put C. If you're still confused about end behavior, put D. And give me an E if everything makes sense. Okay, so whoever put F as an option, it's not an option. Okay, so I don't really know what the F means. Is it just like an overall, I don't know, maybe? Oh, Brandon, I just saw your message. That is correct. Thank you. Okay, so it seems like in general, we're still a little bit confused as to what this infinity thing is and behavior. And hopefully you can clear those confusions with the next two examples, okay? So we're gonna launch poll with the next two examples as well. And hopefully we can all move to E, but that's okay. It's a new concept, it might take time. All right, we're gonna move on to our next example. Okay, so in this example, it tells us to match the letters with the correct terms. So for the zeros, oh, actually, I can launch another poll. All right, so can you guys tell me what letters correspond to my zeros? I'm pretty sure you can choose multiple. See, there's a plural form, zeros, so you should have 2 zeros. Zeros meaning when y equals 0, so where my function touches the x-axis, the x-axis. All right. Let me have this as a guide. Okay. Okay, I think most of us got the 2 points. So I'm going to write it down. It's okay if we're still a little confused. So as the majority of you guys said, our zeros are at A and D, and that is correct because you see how our function, the red line, touches the highlighted x-axis at A and D, right? And that's how you tell the zeros. All right, I'm gonna highlight the Y. This time, can you guys private message me what the y-intercept is? That's correct, Roxana. That's awesome. But I want to see if I can get a few more answers. If I can get a few more answers. Feel free to come off mute or private message me. I've received a few messages, but still waiting for more. Thank you, Brandon. Take a few more seconds to think about where the y-intercept is. And your hint is this highlighted line. This is your hint. Great. So as mentioned with the previous example, to find the y-intercept, we just want to find the point on our function that is touching the y-axis, right? So this point in this example will be at C. All right, this is a little bit tricky. Remember how we said we have to put a box around parabolas? Okay, we're gonna put boxes too. All right. So let's try to find local maximums. Can you guys have a guess? So what's left, I think, are points B, E, and F. So which one or which ones? It might be two. There might be two options. No, Amira just got your answer. Thank you. What is my local maximum? Ooh, those are really good answers. Okay, so I have an answer asking, isn't it only B, right? That is a good observation. But you see how B, if we draw this box around B, is it at the lowest point or the highest point? Yeah, it's at the lowest point, right? So maximum meaning the highest point and minimum meaning the lowest point. So that's a great observation. You got one of them, all right? And I have others telling me both E and F. That's also a good observation. It's a little bit tricky. So here I'm going to show you. Yeah. So the answer is actually just E. Okay. So I can tell how E and F could be confusing. So let's try. Yeah, exactly, Josh. So let's try to box around both E and F. Okay. So if you look at E and F, right? The parabola with the curves. So we have two curves. They look a little bit similar, but you can tell that E is higher than F, right? And F is, on the other hand, very low. It's like the lowest point of that curve. So our local maximum is actually just E. But I've got really good observations and really good responses. Okay, so how can I find my local minimums or minimum? That there could be two, there could be multiple, but where are my minimums? Yeah, B and maybe F, right? I'm gonna draw out the boxes. So how I usually draw my box is I draw a box immediately before and after a curve. So you see my box is kind of small. It's because I see the curve is right here, right? So I want to have it around this point. And then the other is right here. So I see that at B, this is the lowest point within the box, right? Because all those points are higher than B. So I know, hey, B is a local minimum. And same for F. F right here is a very low point at this curve. It's the lowest point of this curve. And that's how I know it's a local minimum. So local minimums at B and F. Great observations and great responses, everyone. Okay, so here comes the tricky part. The end behavior. We're going to start by looking at when x approaches infinity, right? We talked about how when x approaches infinity, it means that we are going very far to the right. So what do I have to do? What does the function tell us when x approaches infinity, when x goes very far to the right? What part of my function should I be looking at? Come up mute if you think it's easier to respond that way, or private message me. I've gotten really great messages so far. Yeah. So we want to look at the left side. That is correct. We want to look at the end of the left side. Wait, no, of the right side. I'm sorry. You're right. Thank you for the correction. You want to look at the end of the right side. So because it's moving upward, we're going to say y is also approaching infinity. Okay? Because when our x gets really big, meaning it goes really far to the right, you see the end of our function right here on the right side, right here, is also going upward, right? Because this is going upward, I know that when it's going up, then y is also approaching infinity. If it's going down at the end, then y is approaching negative infinity. So those are the directions. Okay. All right. So on the other hand, how do I tell what my function is going up or down when x is approaching negative infinity? meaning it's going very, very far to the left. What area of my function should I be looking at? Yeah, we want to look at the end of our left side of the function. So we're looking at here. And you see that, hey, we're still moving upward. So we know that if we're moving up, if y is moving up, it's y approaching infinity, right? So you see how in the previous example we have an infinity and then a negative infinity, right? You can have two positive infinities, like two infinities and two negative infinities. It doesn't have to be either or with the y, right? It has to be either or with the x. It has to be either going very far right or very far left. But for the y's, it really depends on the shape of your function. So here we see that both on the right end and the left end, the function is moving upward, right? We're going upward here, and we're also going upward here. So I know that when x is approaching infinity, moving really far to the right, I'm moving upward. So y is also approaching infinity. When x is going very far to the left, my end of my y on the left side is still moving upward. So y is also approaching infinity when x approaches negative infinity. It sounds a little like a tongue twister, but I hope the concept is starting to make sense. I'm going to launch a poll. All right. And you guys are going to tell me the same thing. So if you're a little bit confused still with, let's say, A for zeros, B for the y-intercept, C for maximums, D for minimums, and then E for end behavior, and F if you are getting it. All right, I think we are moving to more Fs. That's great. But it's okay that we are still confused about different parts. Hopefully with more practice by looking at the next example, we can get those questions cleared. And it'll be really helpful if you guys can tell me like at what point you're confused. For example, if you chose B, you don't really get how we got the y-intercept. If you can private message me about, okay, so how do we get this? That would be really helpful. So I know how to answer or phrase it more to your understanding. Okay, it sounds like the majority of us are starting to understand the concept a little bit better. But it's okay. We still have some doubts to answer, which is great. Hopefully we can get that cleared within the next few minutes. Awesome. Okay, I'm going to end this poll. Great. And we're going to move on to our last example. Let me erase these. Awesome question. So we have a question about what's the difference between maximums and minimums? That's a great question. So maximums, what it means is the highest point of a parabola. So if you have like a curve, right? It looks like this. And maximum is this point. Maximum is the highest point of the curve, the parabola. Versus for a minimum is another curve, right here, but we're at the lowest point. So one way I think about it is when I think maximum, I'm standing at the top of the hill. This is me, Miss Yama, at the top of the hill. That's maximum. Versus if I'm at minimum, I think about, okay, I'm a very low point, so I'm in the valley. So minimum would be at valley. And I spell okay, V-A-L-E-Y, valley, versus for the maximum would be at the hill, at the top of the hill. Okay, does that answer the question? Does it clarify? All right, awesome. It's a very silly reminder, but hopefully that's helpful. Great. Okay, awesome question, awesome question. All right, let's look at our last example. Let me erase those unnecessary parts to this example so we don't get confused. So here is the function y equals 0.4 times x plus 3 times x minus 2 times x minus 3. So as always, we want to find our zeros. And how do we find our zeros? All right, I'm going to give you the cheat sheet. This is our cheat sheet to finding zeros. If you want to private message me your responses, oh, just got one. That's awesome. Thank you. Yes, exactly. So to get our zeros, all we have to do is to draw a line on the x-axis. This is our x-axis. And wherever our function, this is our y function, wherever our y function touches x-axis, these are our zeros. Okay. So we have zeros at -3, 2, and 3. Other way to look at zeros is to look at the function. So we look at the function right here. This is our y function. And all we have to do is we have to flip the signs. We have to flip the signs. Essentially what we're doing is if we have a 3, by introducing a -3 in the x, we have -3 plus 3, which is 0. 0 multiplied by anything gives us 0, right? So in this case, we can't use x equals 0 because 0 plus 3 is 3. 0 minus 2 is -2. 0 minus 3 is -3. So having x equals 0 doesn't always solve the solution. That's just like a soft reminder. All right, so you can find zeros by looking at where our function intersects with the x-axis, or we look into our function, the return equation, and we flip the signs of wherever we have zeros. We have x. Okay, awesome. So that's how we find zeros. Next question is how to find the y-intercept. 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 Here, I'm going to give you another cheat sheet. All right. Great. Roxana, that's awesome. You want to come off mute and tell us how you got 7?
I got 7 because it's not the bottom, so it's at the top. And the point right there.
Okay, that's cool. You mean this point, right?
Yes.
Okay, so that's correct. So Roxana got 7 because you see our function touches our y-axis at 7. I think that's what you were trying to say, right? Cool, awesome. So our y-axis is at 7. Okay. All right, and then we have the second question is maximum and minimums, right? Max and minimum. We're gonna find maximum first. We're gonna find maximum. Okay, we're gonna draw boxes around anything that looks curvy, that looks like a parabola. Yes, Noemi, you're correct. It is at 9.5. Oh, I don't want to take you guys away from your class time, so we're gonna have to rush a little bit. Sorry. So you are correct. It's at when y is at 9.5, when our y is at 9.5, and then when our x is this straight? Okay, this looks straight. When x is at -1. So our local maximum is at -1 and 9.5. All right. And our local minimum, okay, that is correct, Naomi. You've been giving me the y values though. Remember, we need both x and y. So you're correct. Our y is here and the x is here. Let me try to draw this box. And this is the box that we have because we have that curve, right? And this is the lowest point of the curve. So our minimum is at x when x is 2.5 and my y is -0.5. All right, the last bit is end behavior. So what happens when x approaches infinity? When x approaches infinity, meaning this way. X approaches infinity. What happens? We're looking at this, right? When x approaches infinity, it's moving very far to the right. So we want to look at the end of our function on the right side. So this is the end of the function. Yes, it's positive infinity. So here we see as x approaches infinity, as x goes really far to the right. Oh, that's an eraser. I don't need an eraser. Our y also approaches infinity. That is great. Thank you. All right, second question. And last question before I let you guys go is when x approaches negative infinity, what happens to y? So negative infinity, meaning x is very, very far to the left. And remember, if it's very far to the left, we want to see the end of the function when it's on the left side. So the green circle right here is the direction that we're looking at. Cool. Go ahead, Jacqueline. Miss Flores. Negative infinity. You're right. Because we're moving very far to the left with the x, our function is still moving downward, right? So that's what happens. Cool. All right, so this is our lesson, and we worked on maximums and minimums, which is great. And then we also worked on end behaviors when x is approaching infinity and approaching negative infinity. So make sure you have the notes taken, which is great, and just post and slap on your assignment. And assignment 37 is also found on Canvas. Okay. All right, guys. Thank you for a great lesson. I think Miss Flores just opened breakout rooms for students who want to work with her. That's great. If you have questions for me, come back during office hours, okay? And that's it. Thank you, guys. Feel free to sign off, okay? I'm gonna let in the accelerated kids, the pre-calc kids. Bye-bye. Bye.